So I'm finally going to get this Arduino Due out of the box. I actually bought it, I think I got it like in December, something like that. So I've just been real busy. Just started a new job. I was doing some renovations on the house and some other things, other real life stuff I had to take care of. So I haven't had the time I wanted to spend on my videos lately. I'm going to get back into it, and this is just going to be a quick unboxing video. Comes in a kind of crappy packaging, really, for a high-end little kit like this. But let's take a look. Yeah, not much in here, just a board. Whatever this is. This is just a warranty statement. There's really no need for any documentation these days. Everything's online. I did see that to actually use this board, you have to download the beta version of Arduino. It's like 1.5.2 right now, so I already got that downloaded. But just going to take a quick look at this board. I think it's got about the same capabilities as the Mega, with a few extra I/O stuff, and it's got these it's got micro USB connectors here and here. I think you can actually act as a host. That's one of the really cool things. And another thing, this package here, this Atmel, trying to see what that is. Anyway, it's Atmel's it's ARM. I can't remember which ARM it is, but one of the major things about this board is it's well, it's super fast for one. It's got all kind of features, but it's also 3.3 volts. So I'm gonna have to be careful when I use any of my 5-volt devices. So I want to go ahead and there's not really much to unbox. The only cool thing in here really are these stickers. They're kind of neat. Open source Arduino. It's got a hack sticker. Those are kind of neat, but I think what I need to do is go ahead and do a quick build. So I'll be right back. Okay, so now we're just going to set up a quick LED blinky thing, and I just want to test out this resistor because I don't feel like reading it. I'd rather just measure it. So I'll just hook this up and we'll see what size resistor this is. And it looks like that's about 180 ohm resistor. So that should be fine. Looks like this is a voltage regulator circuitry here to bring it down to the 3.3. Also a similar, I guess that's a capacitor there, some kind of filtered cap or something. And I think this is a little voltage regulator. It's a real small package. That's an interesting little design they have. But anyway, I'm going to go ahead and plug this in now. And I just have this cable plugged into a wall wart. See if we get our 3.3 volts out. And also we can see what the default program is on this thing. I'll turn the light out so you can see it. I mean, it's not that cool. It's just a the LED blinking program again. And it looks like they do have a very small transistor there. I mean, a resistor. says 102. I'm not sure what that is. I'm gonna look it up real quick. I'm curious. Okay, for those of you familiar with SMD codes, you probably already knew it, but 102 is actually a 1 kilo ohm resistor, so that makes sense. They're using a 1 kilo ohm resistor on that LED. So what I want to do first was just take a look. Just leave this off to the side. Go ahead and take a look at the voltages coming off of this Arduino. Let me grab a few jumper wires. So you may notice I'm using a complete dog shit excuse for a multimeter here. So if any of you watching this show right now happen to work for Fluke or some other high-end test equipment company, I am for sale. You send me a Fluke and I'll do a spot for you, I promise. So anyway, oh, that's interesting. This is a 3.3 volt system, but there is actually 5 volt DC here that you can get to on the board, so that's cool. I just want to take a look at the 3.3 volts just to make sure the regulator is working properly. So I'll actually plug in here. And then look up here and here, and we'll take a measurement. And yeah, I really do. Seriously, I need to upgrade this multimeter situation because it's not good. Although this is reading 3.29 volts, so it looks like that regulator is good. And while we're at it, we might as well go ahead and just take a look at the 5 volt output here. And that's interesting. We're actually reading, looks like 4.78 volts. So I'm wondering if that's maybe that's the voltage straight off the charger. It's got to be. That's probably the voltage right off the charger, either that or that's the drop we're getting from going through a regulator. I'm not quite sure how this is set up. I'm not sure, but I have a feeling that if I came through this barrel jack with 9 volts, I bet I'd get a clean 5 volts there. But I'm not going to use 5 volts anyway. So I did say we're using a 180 ohm resistor today. Okay, so now we're just going to go ahead and test out this LED for fun. I've got the 180 ohm resistor there. And I've got the short leg. Hooking up to the resistor. I guess I'll turn that around so you guys can see it. And this is kind of a weird LED here. It's a little right angle thing I got from a surplus house. Then go ahead and hook this up to 3.3 volts. And very pretty. We got LED there. So LED works, we're good to go. I'm not real happy with how bright the LED is. I think this LED might be maybe a little more of a robust LED than I wanted to use. So let me see what else I can find. I want something that'll get a little brighter. Okay, so I got my little bag of weird LEDs that I got from the surplus warehouse. And these are pretty cool. You get a bunch of like different things, like this little square looking one. The only thing is I have no idea like what the voltage drop is on these. Oh, here's like a pink one in here. Let me see. This might be cool. And look, there's some like little 3 millimeters, stuff like that. But it's nice when you have a known size, because then you can kind of plan your resistance out a little better. So anyway, let's see. That. Okay, that's the hot side there. Let's see what this one looks like. There we go, that's what I'm talking about. That's a little brighter. You can probably already see it even without the light out. That's a lot brighter. And just out of curiosity, I want to see what this other one looks like too. This square one, I don't think I've ever seen one of these lit up yet. That's kind of cool actually. Sorry, my multimeter's bitching at me. That's pretty neat. It's not so like in your face. You can tell that's made to go on a front panel. That's pretty cool. Kind of like that one. So anyway, we'll go ahead and go with that for now. So I'm glancing at this board because I do want to do PWM with this first little program, and it looks like without reading the documentation, it looks like pins 2 through 13 are labeled as PWM, so that's not bad. You get 12 PWMs. So I'll go ahead and set that up on just some random number 7. We'll go for number 7, and then I'll go over to the computer real quick and whip up some code and hopefully upload it. Okay, so go ahead and open up Arduino 1.5.2 for the first time, and I imagine I'm going to have to use these drivers here because I've never actually connected this board before. But anyway, let's go ahead and take a look at the new software, see if there's anything different about it. This looks the same so far, and what I'm going to do on this, I actually wrote a sketch last night, a quick sketch, and this is it. We'll run through it real quick. This sets up the LED as pin 7. This is a wait time that I did in between steps of the PWM. It's going from 0 to 255, and here it's stepping by 5, but I think that since this processor is running so fast, which I'm going to have to get used to, I'm going to go ahead and use steps of 1, and it still might be too fast because I did put a wait here that's in this delay statement, and it's just 2 parts of this loop. It's going up to 255 and then down from 255 to 0, and then it does it over again. So it's very simple. The hardest part's probably going to be just getting this thing connected. Okay, so off camera right now, I just plugged in my I just plugged in the Dewey for the first time, and you see it's asking for, or it says it's installing device driver software. I don't expect it to find it, so I'm gonna I was kind of hoping it would come up with the dialog where I can install the software. Oh, there it is. There. No driver found. Skip. Yes. Oh. Alright. So it looks like I'm going to have to go ahead and do this the hard way. Here we go. Install software for the device. I've never actually done it like this. Okay, so if you look at my device manager here, you see the Arduino Due is actually shown here, and it's kind of cool looking. I've never actually seen the board listed in this kind of view. Maybe I haven't looked. Anyway, I'll just go to properties. Blah, blah, blah. Okay. Oh, here we go. Driver. Okay, so I'm looking for the place where I can actually upload the driver. Might be under change settings. Let's see. Update driver. Here we go. Now we're on to something. It's not going to be there. There we go. It's going to be in the Arduino. Drivers. I don't know what static is. Hopefully it's going to be in this i386 folder. Oh. Oh Lord, what a pain in the ass. Oh, I don't want to pick. Let's see, maybe if I just go to the top level of this drivers folder, I can find it. Okay, cool. There we go. That's all you got to do. Top level of the drivers folder. And I'm sure it's going to say it's an unsigned driver. But whatever. Okay, so it took a little longer than I thought, but it actually found it. Windows has finished installing the driver device for the software Arduino Due. So that's cool. It's done. And the cool thing is it didn't actually come up. I know when I used to do the driver for the Uno, it would actually come up with a like not valid or unsigned or not trusted, some kind of crap like that. I don't remember what it was. So I need to set the serial port and the board and Arduino Due. And look, you can access it one of two ways here. You can access a programming port or native USB port. Huh. So that's interesting. I have to read up more on these two modes. Okay, so let's go ahead and we'll verify our program. Make sure it compiles first. Which I could have done that all in one step, but I like to. Man, that took a long time. And whoa, that sketch really compiled big. Look, it compiled to 25, almost 26K for this. Wow. There must be a lot of overhead on this Dewey, because I just compiled this code for the Uno yesterday, and I think it used like 1K. So anyway, I'll go ahead and upload this now. And after I click upload, I'm going to go ahead and switch over to the move this stuff so I can switch over to the view so y'all can see it when it works. And I'll click upload. I'm just going to compile that monster again. Jesus. And let me see if I can get this focus for you guys. Okay. Not necessary. Oh, now I got another message on Windows saying BOSA program port on COM8 device driver software installed successfully. So that's telling me that I must have had the wrong COM port. Oh look, it changed it. It was COM7 just a second ago, so let's just change that. Must have not been done installing yet. Still got the Dewey. And I'm going to try uploading again. Let's see what happens. Almost there. SAM BA operation failed. Okay, a little more troubleshooting. Okay, so I just took a look at my board here, and would you believe, probably would, but would you believe that, let's see if I can focus on this thing. Trying to focus. Alright, anyway, got native USB here and programming here, and of course I was in the wrong one. Who'd have thunk it? Okay, now it's coming up with installing device driver software again on the computer. So let's take a look at this. Okay, great news. It looks like it's successful, but now we're on COM 9. So I must have the native on COM 8. No, now it's just COM 9. So now we're going from 7 to 8 to 9. And some of you are probably screaming that I'm a blithering idiot right about now. And I'll admit I'm a little ignorant on this. So I hit upload. And it looks like it's taken it. And now it's verifying. Huh. That's kind of time consuming. It's very verbose now. Let's take a look at our board and see what we got. Okay, well, nothing to see there, of course, because all the action is going to be taking place right here. And isn't that exciting? Our very own little PWM blink routine. And it's a little better than the standard blink. You know, it's not so garish and in your face. Brings you up slowly and then brings you back down just as slow instead of flash, flash, flash. But yeah, so in this video we unboxed, tested out the voltage regulator, hooked up a small circuit, little LED and resistor circuit, installed some drivers, uploaded successfully finally, and got this thing working. So I'm looking forward to doing some more projects in the future. Thanks for watching.